महादेव, मोहम्मद, मोहम्मद, कीर्ति,
Present, sir.
ओके, पिकेश, प्रज्वल गौड़ा, प्रज्वल गौड़ा, रमेश,
Present, sir.
राइट, रतन,
Present, sir.
राइट, रोहन, ऋतिक चोपड़े, ऋतिक चोपड़े, ऋत्विक गुणे,
Present, sir.
राइट, सदाशिव, सदाशिव, सागर, सागर, साई प्रकाश,
Present, sir.
राइट, समीर अहमद,
Present, sir.
ओके, सानिया, संजय, संजय, संकल्प, संकेत,
Yes, sir.
राइट, शिरज, शिरज, शिवनंदा नाटिकर, शिवनंदा नाटिकर, श्रद्धा, श्रद्धा, शुभम, सुमित, सुमित, सुरैया बानो,
Present, sir.
राइट, तेजस, तेजस, विवेक,
Yes, sir. Yes.
ओके, यमुनप्पा, यमुनप्पा, गांवकर रजत रामचंद्र, गांवकर रजत रामचंद्र, मंजुनाथ, मंजुनाथ, प्रथमेश,
Present.
ओके, जोसलिनो, जोसलिनो, सोहम, सोहम, अतिया, अतिया, okay, anybody else joined?
Excuse me, sir.
Yes,
Sir, Rutik Chopra is present, sir.
I have marked yours, Hrithik Chopde, okay, right. Anybody else?
Sir, Janvi present, sir.
I have marked yours. Anybody else? Shubham present. Anybody else? Okay. You're able to see the screen here?
Yes, sir.
Right. Today I'll be discussing about the common base configuration and we'll solve one or two examples. This is the common base configuration that we have already studied. Right, it is a PNP transistor, arrows pointing inward into the transistor. It is PNP transistor. The input current, that is emitter current, is flowing into the transistor. The base current is also flowing into the transistor because of the power supply here, VCC, positive to negative. Base current is flowing inside, whereas the collector current is moving away from the transistor. Emitter current and the base current, they are moving into the transistor, whereas the collector current is moving away from the transistor. The input voltage is Vi, input impedance Zi, emitter resistance Re, voltage source VEE at the emitter terminal, collector resistance RC, and the voltage at the collector terminal is VCC. Voltage connected to the collector terminal is VCC. Output voltage is V0, output impedance is Z0. And the current which is flowing into the circuit, it is II, input current, and the current which is flowing away from the collector terminal, it is IC, that is the collector current. Then the current which is shown here, that is I0, it is flowing into the circuit according to the convention that the main input current and the output current should be into the circuit. According to that convention, this I0 is shown here. This is about the common base configuration circuit. Common base configuration, right? Then here we are replacing this circuit, or we are finding the hybrid equivalent circuit of the common base configuration. This is the common base configuration, right? Of this common base configuration, we are writing the, or we are drawing the hybrid equivalent circuit. The hybrid equivalent circuit of the common base configuration looks like this. We have already studied the hybrid equivalent circuit for the common base configuration in our earlier classes. Here, this is HIB, this is HIB, right? HIB resistance, and here we have HFB IE. It is for the common base configuration. Therefore, this is nothing but alpha IE. For common emitter configuration and common collector configuration, we have beta, whereas for common base configuration, we have the current gain as alpha. This is alpha IE or HFB IE. And this resistance Re, this is the resistance which is connected here, this resistance, emitter resistance. It is connected between emitter terminal to base terminal, emitter terminal to base terminal. That is what it is shown here. This is base terminal, common base. This side is emitter and the output side is collector. This is connected in between the emitter terminal and the base terminal, Re. Then RC resistance, this RC resistance, let us see where it is connected. This is connected between the collector terminal, output side is collector, collector terminal and the base terminal. It is common base. Base is common between the input section and the output section. Therefore, this resistance RC is connected between the collector terminal and the base terminal. That is shown here. It is connected between the collector terminal and the base terminal. Then other parameters are Zi input impedance, Vi input voltage, II input current. The current flowing through HIB, it is emitter current, because it is a current flowing through into the emitter terminal. Therefore, it is IE, right? It is. Then here we have HFBI, alpha I, this one, the controlled current source, HFBI or alpha IE. Then this is a resistance RC, current flowing into the circuit is I0, output current, output impedance Z0, and the output voltage V0. Now for this circuit, we are finding the performance parameters. We are finding the performance parameters for the hybrid model, approximate hybrid model of the common base configuration. This is all we have already dealt with, this portion, HIB, HFB, IE. Only we are replacing the other portion here, that is RE, that is this end, this RE, and this is RC that we are showing here, RE and RC, right? Then first one is input impedance Zi. What is the input impedance Zi? This is the impedance which is seen from the input terminal, that is between positive and negative of the input side, as looking from this end. The arrow is showing that direction from where we are seeing. That end, how much is the impedance? That is the input impedance. If we look from this side, right, towards the positive to negative terminal, RE and HIB will come in parallel. This RE and HIB will come in parallel. Therefore, input impedance Zi will be RE parallel HIB. Zi will be RE parallel HIB. What about the output side? Output side, we have output impedance, that is looking from this end, from the output terminal end, positive to negative. The output impedance Z0 is nothing but simply RC. It is equal to only the collector resistance RC, Z0 equal to RC. Therefore, here we have Z0 equal to RC. Take it as second equation. Next, voltage gain. Voltage gain is EV, right? We know what is voltage gain. It is the ratio of output voltage to input voltage. Voltage gain is a ratio of output to input voltage. This V naught is given by here. If we see this here, V naught, right? That is current entering positive, current leaving negative, current entering positive this end towards the negative end, then towards the other end positive, and it is negative. Positive to negative minus I naught RC, and positive to negative minus V naught equal to 0. What is the equation here? Equation is minus I naught RC minus I naught RC I naught RC minus V naught output voltage is equal to 0, or we have V naught is equal to minus I naught RC, minus I naught into RC, is it not? V naught is minus I naught into RC. How we got this? Looking into this circuit. Okay, current entering is positive, current entering is positive. Okay, here current entering positive, current leaving negative. Positive to negative minus I naught RC, then positive to negative clockwise direction. Okay, take the output loop here. Positive to negative minus I naught RC, positive to negative minus V naught equal to 0, or V naught is equal to minus I naught into RC. That is, V naught is minus I naught into RC. Then what is I naught? I naught is nothing but HFBI. There is no resistance here in between this. So I naught is nothing but the current HFBI. I naught is the current HFBI. There is the same current I naught which is flowing here, the controlled current source. That is, I naught is equal to HFBI. Replace I naught by HFBI. Wherever it is I naught, replace it by HFBI. Therefore, this will be equal to V naught is equal to minus of HFBI into RC, because minus of I naught is HFBI, minus of HFBI into RC. Then find out equation for IE. This one, emitter current. Emitter current, we know that it is a ratio of voltage to resistance according to the Ohm's law. Voltage across this end between these two terminals, between these two ends is VI, that is the input voltage, it is in parallel VI, and the resistance is HIV. Therefore, IE will be equal to VI divided by HIV. IE will be equal to the input voltage VI, it is in parallel, that divided by HIV. That is, IE is equal to VI by HIV. Here in this equation, above equation, substitute for IE. Therefore, V naught will be equal to minus HFB. IE is VI by HIV according to this equation. VI by HIV into RC. What we want the equation for output voltage to input voltage. V naught by VI. Therefore, AV is equal to V naught by VI. This is V naught here. Other end is VI. Take it to the LHS. V naught by VI. This is equal to minus HFB RC divided by HIV. AV is equal to V naught, take VI to the LHS, it will come to denominator. V naught upon VI is equal to minus HFB into RC divided by HIV. Take it as equation 3. This is the equation for the voltage gain. Next, find out the equation for the current gain. Current gain AI. Current gain AI, it is the ratio of output current to input current. I naught divided by II. What is I naught? Output current. Output current is the same thing just we discussed. I naught is nothing but the same current HFB IE. I naught is equal to HFB IE. That is, write it here. I naught is equal to HFB IE. This divided by II, input current. Input current, it is the sum of the current flowing through this resistance RE and the current flowing through HIB. The input current II is the sum of current flowing through RE and the current flowing through HIB. Right? That is, II is equal to IR or IRE plus IE. II input current is equal to IRE or IR plus this current IE. Yes. It is II is equal to IR plus IE. Here, the value of IR, the value of IR, this resistance RE is very high. It's a large resistance. Hence, the current flowing through this resistance RE is negligible. As the value of RE, the emitter resistance is larger in the common base configuration. Therefore, the current flowing through the resistance RE is negligible. Hence, it is neglected. The current IRE or IR is neglected, and the current flows through HIB. The input current II, it flows through HIB. The current flowing through RE is very less. Therefore, what we get here, IR plus IE will be approximately equal to I. The value of IR is negligible, it is neglected, it is almost zero. Therefore, IR plus IE is approximately equal to I. Now, substitute this IR plus IE as IE in this equation, above equation. HFB IE divided by IE. IR plus IE is IE and IE will cancel, that will be equal to HFB. What is HFB? Try to recollect what we discussed when studying the relation between hybrid model and the RE model. Right? Relation between hybrid model and the RE model, HFB is equal to minus alpha. This HFB parameter, hybrid parameter, is equal to minus alpha. That is approximately equal to minus 1. Because the value of alpha is approximately 1. Therefore, as HFB is equal to minus alpha, that is HFB will be approximately equal to minus 1. Clear here, students? This performance parameters is clear here for the common base configuration. Is it understood? Yes. Common base configuration performance parameters is understood here. Yes.
Yes, sir.
Clear, everyone? What about others? Any doubts? Ankita, any doubt? Chandrasekhar?
Yes, sir. No doubt, sir.
Okay.
Clear, sir.
Clear? Fine. Sanket, any doubt?
No, sir.
Sanket? Clear, no?
Yes, sir.
Okay, right. Next, we'll take up one example. Note down this example quickly. For the network of figure below, determine Zi, Z0, AV, and AI. For the network of figure below, determine input impedance, output impedance, voltage gain, and the current gain AI. Note down this circuit here. Input voltage is Vi, input current II, input impedance Zi, C1 input capacitance, then Re is 2.2K emitter resistance, then VEE, the voltage connected to the emitter terminal, it is 4 volts, common base configuration, it is PNP transistor. Then here we have the RC, collector resistance RC 3.3K, VCC. Note that VCC is not the supply voltage to the circuit, it is the voltage which is connected to the collector terminal. The voltage which is connected to the collector terminal is 10 volts. The capacitance at the output terminal is C2, output voltage V0, and output impedance Z0. Then we have the parameters here. HFB minus 0.99. Right, we'll discuss that. HIB 14.3 ohms, HOB is 0.5 microampere per volt. Noted down here. Shubham, noted down.
Yes, sir.
Okay, right. Then we'll solve the example here. See here, what is ZI? According to the previous formula that we derived, RE parallel HIB. ZI input impedance is RE parallel HIB. Emitter resistance is given in the circuit. It is 2.2K. HIB is also given 14.3 ohms. So let us take parallel combination of 2.2K and 14.3 ohms. That is ZI is 2.2K parallel 14.3 ohms. Calculate how much it is. 2.2K parallel with 14.3 ohms. How much you are getting? 2.2K parallel 14.3 ohms. What is the answer? Suraya Banu? Suraya Banu? Tejas? Tejas? How much you are getting? Vivek? Vivek? Pratmesh? Pratmesh? How much you are getting? Rutik Chopde? What is the answer? Rutvik Gune? Gune?
Yes, sir.
What is the answer?
Sir, I'm calculating. Sir, can you explain it once again, sir?
ZI, just now we derived the formula. ZI is RE parallel HIB. RE parallel HIB. Okay. RE is what? Emitter resistance, this resistance 2.2K. HIB is given here. These parameters are given. HIB is 14.3 ohms. 2.2K parallel with 14.3 ohm is how much? 2.2K parallel with 14.3 ohms. Calculate and tell me quickly. Who calculated? Anybody calculated?
Sir, 1.9.
1.9, just check. Anybody getting different answer?
14.21.
Yes, 14.21 ohms. 14.21 ohms. Because RE is larger, 2.2K, then HIB is small as compared to RE, it is small, it is 14.3 ohms just. Therefore, the parallel combination of 2.2K, that is large resistance with small resistance, the equivalent resistance will be the smaller value, right? Therefore, this will be 2.2K parallel 14.3 ohms, we will be getting 14.21 ohms, right? 14.21 ohms, mark that is approximately equal to HIB. Because RE is large, HIB is less, parallel combination will be equal to the smaller value, equivalent resistance HIB. Therefore, 14.21 is approximately equal to HIB to 1 ohms. right? Next, find out R naught. What is the formula for R naught? Formula for R naught, it is R naught is output side here, R naught is output side here, that is 1 upon HOB, 1 upon HOB. R naught will come here between output terminals, the output resistance, right? That is equal to 1 upon HOB. HOB is the output admittance. HOB is the output admittance. It is HF for common base, HF will become HFB, HI will become HIB, HO will become HOB, right? HIB is the input resistance, HOB is the output resistance, okay? And HFB, it is alpha value. HFB is the alpha value, the current gain, that is output current to input current. It is the ratio of the forward transfer ratio, forward ratio, current ratio, that is output current by input current, that is I naught by II. Got the point here? Therefore, here the R naught is 1 upon HOB. Find out how much it is. Output resistance, it is 1 upon HOB. 1 upon HOB. Admittance is 0.5 microampere per volt. If you want resistance, what you have to do? You have to take the reciprocal, correct? If you take the reciprocal of admittance, you will get the resistance, right? That is R naught will be equal to 1 upon HOB, that is 1 upon 0.5 microampere per volt. How much you are getting? 1 upon 0.5 microampere per volt. What is the answer? How much is 1 upon 0.5 microampere per volt? 0.5 microampere. So it is 1 divided by 0.5 into 10 raised to minus 6. Note that. Because it is 0.5 microampere per volt. Here it is 0.5 microampere per volt. Therefore, 1 divided by 0.5 microampere per volt will be 1 divided by 0.5 into 10 raised to minus 6. So the 10 raised to minus 6, if it goes to numerator, it will be 10 raised to plus 6. Okay. So 1 upon 0.5 into 10 raised to 6. 1 upon 0.5 is how much? 1 divided by 0.5 is 2. 0.5 ones are 0.5 twos are is 1. 0.5 into 2 is 1. Sorry, 0.5 into 2 is 1. Correct. So that will be 2 mega ohms. Just check your answers. Just check your answers. 1 upon R naught. 1 upon R naught will be 1 upon HOB, that is 1 divided by 0.5 microampere per volt. This will come out to 2 mega ohms. All of you getting the answer here? All of you, are you getting the answers?
Yes, sir.
2 mega ohm? Fine. Okay. Next, come to Z naught. Right? What is Z naught? Z naught is this output resistance R naught. Output resistance R naught, whatever just now we calculated, is 1 upon HOB parallel with this resistance RC. If output resistance is not included, then it is different. But if output resistance is included, we have to calculate if output resistance is included, R naught is included. Right? If R naught is included, then the output impedance Z naught will be, that is R naught parallel RC. Right? R naught parallel RC. That is R naught is 1 upon HOB, 1 upon HOB parallel RC. We have already calculated R naught, that is 1 divided by 0.5 microampere per volt. It is 2 mega ohm. 2 mega ohm parallel with RC. 2 mega ohm parallel with RC. That is what I have written here. You can just check this equation. Z naught is equal to 1 upon HOB parallel RC. Z naught is 1 upon HOB parallel RC. Therefore, calculate the value of Z naught. 1 upon HOB, we already got 2 mega ohm. 2 mega ohm parallel RC. RC is 3.3 K. 2 mega ohm parallel with 3.3 K is how much? Calculate quickly. 2 mega ohm parallel with 3.3 K. How much it will be? It will be almost same. 2 mega ohm only will get, because 2 mega ohm is very large value and RC is how much? Just 3.3 K. It is very less as compared to mega ohm. Therefore, 2 mega ohm parallel with 3.3 K will be approximately equal to RC only, that is 3.3 K. What I have written. Z0 is 1 upon HOB parallel RC. It is approximately equal to RC. That is 3.3K. 3.3K. Next, note the equation for AV here. Note down the equation. Gain equation is given by AV is equal to minus HFB RC by HIB. Note down this equation. AV is equal to minus HFB into RC divided by HIB. Gain equation for common base configuration. Approximate hybrid equivalent circuit. Substitute HFB, HIB and RC and calculate the value of AV, voltage gain. Have they given HFB? Just see HFB and HIB. Just see. Yes, they have given HFB 0.99. HIB is also given. RC is given 3.3K collector resistance. Substitute all the values and find the value of AV, voltage gain. AV is equal to minus HFB into RC divided by HIB. Noted on this formula. Then use these values. HFB minus 0.99 minus HFB into RC. RC is 3.3K divided by HIB. HIB is 14.3 ohms. 21 ohms. We have to take 14.21 ohms. I just explained that in the last class. Because these values HFB, HIB, HOB are given by the manufacturer. But according to our design, we are getting the value of HIB as 14.21 ohms. Right, 14.21 ohms. So accordingly, we have to find the value of gain. And HIB is this value according to our designed value, 14.21 ohms. How much is the value of the voltage gain AV? Therefore, AV will be equal to minus of minus 0.99 into 3.3K. This by 14.21 ohms. Calculate the value of AV. Minus of minus 0.99 into 3.3K divided by 14.21 ohms. How much will be AV? Voltage gain? How much? Can anybody tell me the answer? How much you are getting? Minus HFB is minus of minus 0.99 into 3.3K, the whole divided by 14.21. What is the answer? How much you are getting, students? Sai Prakash. Sai Prakash. Samir Ahmad. Kaji. What is the answer?
Getting 23.
Yes. How much? 1823.
23, sir.
23. Only 23. Just check. It will be 229.91 approximately.
Yes, sir. Same.
229. Just see.
Yes, sir. 229.
Correct, no? Fine. 229.91. Okay. Just all of you cross verify your answers. The voltage gain value will be 229.91. Here it is. 229.91. Then finally current gain AI. AI is HFB, approximately HFB. According to our whatever we have derived performance parameter. AI is HFB, that is approximately minus 1. The AI is at HFB. HFB, what value they have given here? HFB is minus 0.99. Minus 0.99 is given. That is minus 1 approximately. HFB is minus 0.99. It is approximately minus 1. Therefore, current gain is approximately HFB, that is equal to minus 1. Right? Is this example understood here, students? Is it clear? This example is clear to everyone? Yes?
Yes, sir.
Okay. Let us quickly move on to the next example. This example, note down this. Given I is equal to 2.5 milliampere, HF equal to 140, HOE equal to 20 microsiemens, HOB is equal to 0.5 microsiemens. Determine first one common emitter hybrid equivalent circuit, second one common base RE model. Given I is 2.5 milliampere, HFE 140, HOE 20 microsiemens, HOB 0.5 microsiemens. Determine first one common emitter hybrid equivalent circuit, second one common base RE model. Note down the question. Did you all note down, students? Kirti? Kirti? Janvi? Janvi?
Yes.
Chandrasekhar?
Yes, sir.
Noted down
Yes,
the
sir. Yes, sir.
example? Okay. Noted down the example? Noted down the example? Okay. Right. See here, first one, what they have asked, common emitter hybrid equivalent circuit. So you have to remember the common emitter hybrid equivalent circuit. Okay. So what is a common emitter hybrid equivalent circuit? This is how it is. Emitter is common between input section and the output section. Emitter terminal here we have between input section and the output section. It is common to both. Input side is base, output side is collector. Then here we have the resistance HIE for the common emitter hybrid equivalent circuit. It is hybrid equivalent circuit. HIE, this is common emitter, therefore it is beta IB. This is beta IB, IC value. IC is beta IB, right? That is 140 into IB. Okay, that we'll see how we are getting that. Then the output resistance is 1 upon HOE. Output resistance is 1 upon HOE. Therefore, what we are supposed to do here is first draw this common emitter hybrid equivalent circuit and write the different parameters, that is HIE, IB, then beta times IB or HF. This will be HFE IB, HFE IB, HFE IB. Then this is R naught output resistance 1 upon HOE. It is reciprocal of output admittance. Resistance is reciprocal of output admittance, right? First draw this figure, then we have to find out the different parameters. Quickly draw this figure, note down this. This is nothing but already we have studied this. It is the hybrid equivalent circuit of common emitter configuration. Note down this quickly. Did you all note down here? Vivek? Tejas? Tejas? Suraya Bano. Suraya Bano. Shubham. Shubham Bekwadkar. Did you all note down
Yes, sir.
here? Noted down the
Yes, sir.
circuit, this one? Model?
Yes, sir.
Fine. Okay. Good. Let us now find out the performance parameters. Now see, if we want to find this HIE, how much is this HIE, right? While studying the comparison between the hybrid model and the RE model of the common emitter configuration. Hybrid model of common emitter configuration and the RE model of common emitter configuration, when we compare them, then this HI will be equal to beta RE, right? That beta RE term will come for the common emitter configuration. Therefore, this HI will be equal to beta RE. This HI is beta RE. We know beta. Beta is given, that is HFE. This value, what is there? This 140 IB, that is nothing but the beta value. It is HFB IB or the beta IB. For hybrid model, it will be HFB IB. For the RE model, it will be beta IB. That is how we have to consider. Therefore, we know beta, we don't know RE. Small RE, we don't know. We have to calculate that. If we want to calculate small RE, what is the formula? RE is equal to 26 millivolt by IE. Small RE is 26 millivolt by IE. This is a standard formula. That is 26 millivolt by emitter current is given already. It is 2.5 milliampere. Substitute that, the answer will come out to 10.4 ohms. Just verify your answers. 26 millivolt by 2.5 milliampere will be 10.4 ohms. Just check. 10.4 ohms.
Yes, sir. Correct.
Okay, fine. Next, substitute this RE value in this equation for HIE. HIE is beta RE. HI is equal to beta RE. That is equal to beta is 140. That is HFE value into small RE. Small RE is 10.4 ohms. Answer will come out to 1.456 kilo ohms. Just check. 1.456 kilo ohms. Just verify your answers, how much you are getting. How much you are getting? Beta RE. Beta is 140. Small RE is 10.4 ohms. 140 into 10.4 ohms. How much you will get? 1.456 kilo ohms. Am I right? Yes or no? 1.456 kilo ohms. Anybody getting the answer?
Yes, sir.
Okay, good. Next, what we are left with? We are left to find the value of output resistance R naught. This is nothing but 1 upon HOE. It is reciprocal of admittance. HOE is the output admittance. If we take reciprocal of this, we will get the output resistance. That is R naught is equal to 1 upon HOE. How much is the HOE given? 1 upon 20 microsiemens. That means 1 upon 20 into 10 raised to minus 6. Calculate how much it is. 1 divided by 20 into 10 raised to minus 6. 1 upon 20 microsiemens. What is the answer? R naught value? Yes, what is the answer? Calculated? Anybody calculated? Ankita? Chandrasekhar?
Sir, doing, sir.
Doing? Okay, calculate. 1 upon HOE, that is 1 divided by 20 microsiemens. One upon 20 into 10 raised to minus 6. Take your calcium and calculate. Don't do it manually. How much you're getting? 50K, exactly, 50K. The value of output resistance R naught is 50 ohms. R naught is 1 upon 20 microsiemens, that is 1 upon HOE, that will be 50 kilo ohms, right? Write down here, 1 upon HOE is 50 kilo ohms, okay? This is the common emitter hybrid equivalent circuit. What they have asked next, part B, common base RE model. Common base RE model. Let's quickly draw the RE model first, common base configuration. This is the RE model of the common base configuration. Here we have only the RE resistance as it is common base, right? RE resistance is there in between emitter to base. Then here we have IE, emitter current, okay? That is alpha I, it is alpha is approximately 1, therefore it will be equal to only I. Then R naught, output resistance R naught we have to calculate. We are supposed to calculate here, one is RE value, then we have to calculate R naught, the output resistance. These two we have to calculate here. I is already given, a value of I is already given. We are supposed to find out RE and R naught. First note down this RE model for the common base configuration. Note down quickly. So for the common base, we are getting alpha IE here, controlled current source, alpha IE. This we have already studied, RE model of the common base configuration. The same thing I have drawn here. Did you all note down the circuit, students? Model you noted down? RE model? You noted down the RE model here? Yes, please. Janvi? Janvi? Rutik Chopde? Janvi noted down the RE model? Okay, right. Let us calculate the performance parameters. RE is already we have calculated. It is 26 millivolt by IE. The previous part A. RE is 26 millivolt by IE. 26 millivolt by IE is given 2.5 milliampere. 26 millivolt by 2.5 milliampere, that will be 10.4 ohms. The same one we'll get because input current IE is same 2.5 milliampere for both common emitter and common base models. Okay, common emitter hybrid equivalent circuit and common base RE model. The IE given is same 2.5 milliampere. Formula is same. RE is 26 millivolt by IE for both. Therefore, the value will also be same 10.4 ohms. It's 10.4 ohm. Alpha is approximately equal to 1. Standard value alpha given by the manufacturer is approximately equal to 1 current gain. Then R naught, how to calculate R naught? Small R naught, output resistance. Output resistance is 1 upon HOB. This is for the common base configuration. The HO will become HOB, right? Similarly, HI will become HIB. HF will become HFB. HR will become HRB, like that for common base. If it is common emitter, HO will become HOE. HI will become HIE, like that, okay? R naught will be 1 upon HOB, that is 1 divided by 0.5 microsiemens. HOB is given in the problem. The problem question they have given HOB 0.5 microsiemens. Right? For the common base. For the common emitter, we have to take HOE. Okay. HO will become HOE, output admittance. Then output admittance for common base will be HOB. That is 1 divided by 0.5 microsiemens. That will give the value of output resistance. Calculate how much you will get. 1 divided by 0.5 microsiemens.
Sir, 2000.
2000
Sir, ohms.
kilo ohms or what it is?
Sir, 2000.
2000 kilo ohms or what it is?
Sir, kilo ohms.
2000 kilo ohms? 2000 kilo ohms you are getting?
Yes, sir.
So 2 into 10 raised to 3.
Mega ohms.
What is the value you are getting? You tell me.
So after calculating, I am getting 2000.
No, what is the unit? Whether it is ohms or mega ohm or kilo ohm? 1 divided by 0.5 microsiemens. Micro means you have to take 10 raised to minus 6. 1 divided by 0.5 into 10 raised to minus 6. 10 raised to minus 6, if you take to the numerator, it will be 10 raised to plus 6. 10 raised to plus 6 divided by 0.5. 1 divided by 0.5 is 2.
Sir, 2
Correct?
mega ohms.
2 into 10 raised to 2 mega ohms. Correct? So it will be 2 mega ohms. Am I right? Therefore, the value of output resistance R naught will be 2 mega ohms. Got the point here? So this is how we have to solve this particular example. If they ask in the examination to draw the hybrid model of the common emitter configuration and the RE model of the common base configuration, to draw the model, and accordingly we have to calculate the different performance parameters. So in today's class, students, we discussed the common base configuration. We started with the common base configuration, right? We discussed about the hybrid approximate model of the common base configuration. Then we derived the various performance parameters. That is RE parallel HIB, Z naught is equal to RC. Then voltage gain AB is equal to minus HFB RC by HIB. Current gain AI is approximately equal to HFB, that is minus 1. Then we discussed two examples. For the first example we discussed was on the common base configuration, hybrid equivalent model, approximate hybrid equivalent model. Then the second example that we discussed was on the common emitter hybrid equivalent circuit and the common base RE model. Here, yes, friends, was it understood today's topics? Was the today's topics understood, students? Ramesh, is it understood? Ramesh? Ratan? Ratan? Birje? Rutik Chopde? Rutik? Rutik Gune? Gune?
Yes, sir.
Is it understood, Rutvik?
Yes, sir.
Okay, fine. Samir Ahmed, Kaji?
Yes, sir.
Kaji? Clear, Samir Ahmed?
Yes.
Okay. Surya Banu? Surya Banu, was it understood? Ankita?
Yes, sir.
Clear, Ankita, today's topics?
Yes, sir, understood.
Okay. Fine. Janvi?
Yes, sir.
Janvi? Clear today's topics, Janvi? Any questions?
Understood, sir.
Any doubts? Understood?
sir.
Any problem in understanding? Okay, fine. Then in the next class, we'll continue with the next one. Miller's theorem is there. Next one, a theorem on the circuits here. That is, the feedback capacitance will come into picture. That we are writing in the form of the Miller's theorem. That we'll discuss in the next class. Okay. Thank you.
Excuse me, sir.
Yes, please.
Sir, I didn't give attendance, sir.
Here. What is your roll number? Tell me.
Sir, 28 Shubham.
Shubham, no? Okay, I will mark. I will mark. Okay. Shubham,
Okay, sir.
Bekwarkar, I have marked already. You are present. No problem.
Okay, sir.
Okay, fine. Right.